Hello everyone. Welcome to this talk. My name is Elie Kfoury. I'm an assistant professor at the University of South Carolina. And I have here also Dr. Jorge Crichigno. Dr. Jorge is a professor at USC too, and he's been leading a cyber training project on P4, which we're gonna be talking about in these slides. Just to go quickly over the agenda for this talk, we're going to start first by the motivation. So why did we start doing this? We started a few years back, creating a cloud where we can perform hands-on training. Then we're going to look at what were the objectives of the first cyber training project, NSF Cybertraining project. So that's all about P4, but the focus was mostly on programmable switches, whether they are software or hardware. Then we're going to introduce the cloud system that we have at the University of South Carolina. Then what are the labs that we developed? And after that, we're going to look at another project that we recently got, and it's more about P4, but for SmartNICs or DPUs. And we're going to also discuss where these labs are going to be deployed. And specifically, we're going to talk about the Fabric best bet and how we can leverage it for education. And finally, at the end of the talk, we're going to provide some information for those interested in going over the labs and see what we have. And if they want to contribute as well, we're going to be talking about how we can do all of that. Dr. Crichigno, would you like to start here? I can stop the share and you can take over.
Sure, Elie. Yeah, let me share my screen and I will continue from there. My name is Jorge Crichigno. As Elie said, I'm a faculty also at the University of South Carolina. And this is a project I teach here, IT, computer science. And this actually came from a previous grant, a previous project. And what we're always trying to do is to do more hands-on in our classes, hands-on education. And this is coming from the IEEE ACM. And when we wrote the first proposal, that was back in 2019, we got 2020, was just on time because what happened in that year, COVID. Also, again, this is coming from NSF. There's a report that is called The Missing Millions, and they need to try to lower the barriers for learners. Think about the undergrad students. What can we do to teach better, make technology more accessible? And this report is a very nice report that talks about what this group of people brought by NSF suggested. For example, lower barriers to entry, build up the controls at the same time, explore investment in research computing or infrastructure to teach more hands-on or help to do research, trying to lower the barrier. So that's what we tried to do with this first project that is started back in 2021, is to how to teach P4, how to include P4 in associate bachelor or graduate degrees. So that's objective number 2 of the project. And the first one was increase and facilitate the adoption of P4 devices. We were thinking P4 switches back then. And when we said here, increase and facilitate the adoption, we're not talking about P4, PhD students, grad students only. What we were talking about is these people that work on campus networks, Department of IT, that are running the actual networks on campus. So how can we train those people on these technologies and technologies that are relevant, such as SDN? What we did is, I'm mixing a little bit 2 projects here, but I think it's worth mentioning. One of the first things that we did was to first deploy this cloud system we call academic cloud. It's a cloud system. And we're not the only one. This is run by 3 organizations. One is University of South Carolina. The second one is the Network Development Group, is a company partner with us in several projects. And the third is the Stanley Community College. So we deploy this system, the cloud where all the material is running. What the cloud does is think about these 3 data centers. Again, we are University of South Carolina, this state here at the East Coast. North Carolina is on top. So University of South Carolina, Stanley Community College is this college in North Carolina. And then the Network Development Group has a data center in Illinois. Idaho National Lab liked it very much what we were doing, so they also put a data center. So in these 4 places, there is a bunch of servers, compute resources, storage. And whenever a student is doing a lab, is hitting one of these data centers. So when a learner wants to, let's say, do an experiment on P4 switches using BMP2, or let's say using Tofino, so it's gonna access the system through a portal and then select through the catalog the appropriate lab library. For example, P4 with BMP2 is one library, or advanced P4 with Tofino is another library. And inside a library, there are, again, several lab experiments, 12, 10, 14, depending on the lab library. So it's gonna pick up one experiment, and then the system is gonna reserve the pod. A pod is a set of equipment needed to do an experiment, and then that will be visualized in the screen of the learner. So what do we have in a data center, such as the one that we have in South Carolina? Just a bunch of servers. We call this host 1, 2, N, and that's where all the virtual machines, all the pods are. Again, a pod consists of virtual devices, sometimes physical devices. Most of the times are just virtual machines, virtual networks, everything that a learner needs to execute an experiment. That's a pod. Then there is a management server that runs a software that we call NetLab, that manage the local system. And then the learners are in the internet. Libraries, we have developed so far since 2020 about more than 15 libraries. And here we're just focusing on some. This is just an example. But for example, if a learner here in South Carolina wants to, let's say, run an experiment on SDN, so it's gonna reserve and it's gonna grab one of these pod, one of these equipment. So that's a high level overview of the infrastructure. This is the data center in North Carolina. So about 9 servers and the compute resources. So really it's just a regular data center, but the key is that they are connected together. As I said, libraries. So what we do in these projects, these 2 projects that Elie showed at the beginning, we develop libraries to teach our students and also to teach IT professionals to help them train on these technologies. So a library consists of between 10, 20 lab experiments. Some libraries include exercises, so because these are used in the classroom. A library, an experiment has a step-by-step manual. We write like a book. I would call a booklet. So really the learner has the theory behind of what is coming next, which is the experiment. And in this website, we list most of our lab libraries. So if you're curious about what we have developed so far, this is up to date. This website is up to date. Most of the libraries. Some of them are not there because NDAs, but most of the libraries are there. An example. So one library could use only virtual devices. So what we call that is fully virtual pod. And these are nice libraries because are very scalable. For example, we have a class of 50 students. What we have to do is just clone this pod of equipment for this lab library. This is an example, cybersecurity fundamentals library. And it's very simple for the learner because the learner doesn't need to focus on setting up the virtual machines, interconnecting the virtual machines, etc. Everything is ready. And then once the pod is designed, what we have is we start developing the lab experiments. In this example, this lab library consists of 19 lab experiments, all sort of exercises. So this is one example of lab library. So to give you an idea how the system look like, so here we have Jose, a learner, is logging into the system. I will pause for a second. He already reserved time in the system, and when the time comes, what the learner will have is the ability to enter the labs. In this case, he's entering the lab. The pod will be initialized and it's gonna be ready. Again, the nice thing here is that everything is ready. And if you didn't notice, the learner is just clicking into the device and opening the device. This is a all virtual pod. So what you see here is a set of virtual machines and virtual networks. There are about 3 networks there. We're emulating internal network, DMC, external network, trying to emulate as realistic as possible. So this is one example. Now, there are some libraries. For example, this is more for grad students, where, and also some of the PhD students use this library. The first thing that my students do is to take this library and go over. When they want to learn, they need to learn, for example, P4 switches with Tofino and start doing some experiments with real hardware. I'm pretty confident this audience know about Tofino, but in case that you never heard, is a physical switch that has a chip that is programmable. And in this case, we have a library that consists of 7 lab experiments, from a very introductory to inspecting resources. And here is the pod. We have a real physical switch, 2 devices, PC1, PC2, a Tofino model, which is a virtual machine. And these real devices are connected with fiber, 100 gig fiber. So in this case, the pod is hybrid because there are physical devices and then some virtual devices such as PC1 and PC2. So in summary, we have the cloud system, but attached to the cloud system, we can also attach the actual hardware. How does this look like when we have this hybrid pods? As you see here, so here we have the learner. I'm pausing for a second, but this is how it looked like, the platform. And whenever the learner wants to do some changes, let's say in the Tofino switch, it's gonna just click on top of on the switch, or it's gonna click on the server. In this example is a learner that a grad student, that is doing some iPerf transfer and then measuring the round trip time with very precise, I mean, it was the nanosecond resolution that is provided by Tofino. Yeah. So about 300,000 nanoseconds round trip time. And here we're emulating, let's say, if the end-to-end delay is increasing by 5 milliseconds. So that is captured by the system. So this is the platform. again, if you are curious to access this, Elie will have more information at the end of the presentation. Some features, allocation of resources. Whenever we design these labs, we have really granular, we can granularly allocate resources, CPUs, memory, if we have switches, the chips. It's easy to create custom pods. Some of the key features, in my opinion, at least when teaching undergrad students, is the presentation layer for the pedagogy. It's very flexible, very easy for an intro learner because all the topology is graphically there. By just clicking into the device, the learner can start making some changes. So, and that was one of the goals from the beginning. The attention of the learner just on doing the P4 code rather than this learning curve, setting the system, the logistics, etc. How to use the cloud? Very easy. I mean, these are just some screen captures, logging into the system, reserving time, selecting. First, we select the lab library. In this case, is P4 switches with BMP2. Selecting the lab experiment or the exercise. The difference between the two is a lab experiment. In this example, we have lab 1, 2, and 3. The labs have a step-by-step directions, so the student cannot miss. And we go through a quality QA, quality assurance that the steps will be there and it's gonna work. We work very hard so that they cannot miss that. On the other hand, the experiment is just do this with very loose directions. We're challenging the student. Reserving the pod. In this example, there are 4 pods. Actually, there are many more if we click here on the right, but it's very simple to enter the system and just start doing the lab. So all the lab manuals, as I said before, this is like a booklet, really. We show everything to the student, and then we show a step-by-step from section 2 to end. Section 1 here is the background, everything that the student has to learn, and then the directions. And I will let Elie go from here. Elie is the main. Elie developed many of these lab libraries. So Elie, do you want to take from here?
Sure. All right. We talked about the lab libraries. This is the example of the first lab library related to P4. And this one is using the BMV2 software switch. So example of lab experiments, just introduction, building the parser, match action table, populating the tables. And these are some of the exercises. So the exercises do not have the step-by-step instruction. So for example, after learning about the parser in lab 4, we will challenge the student to try to parse, for example, the RTP protocol, which is something that they have to go do a little bit of research. Even though everything is provided there in the manual, they might sometimes do more research so that they can solve the exercise. For the development environment, many of these labs that have software switches, BMV2, what we did was we modified the MiniNet graphical editor, which is called MiniEdit, and we added here a P4 switch. And the reason we did that is because when we started learning, I mean, a lot of the time spent was just to construct a custom topology, figure out all how the virtual interfaces are connected and all of that stuff. So now a learner can simply drag and drop. Let's say they want a P4 switch, they want a router where they're gonna run, let's say, FR routing. They want an OpenFlow switch, an SDN controller. All they have to do is just drag and drop and then connect everything. And then part of the lab, they will show them to open Visual Studio Code. We selected this editor it's more than an editor really, because you can see all the files there, the code, and then you have the terminal where you can compile and then push the code directly to those switches. Now, these switches are running Docker. So the BMV2 is running within Docker here. Some example of the labs. So this is how it looks like. You compile using P4C, you push to the switch, you demonstrate how to allocate the virtual interfaces and map them to the logical ports. And then you can see the logs there. We always have the logs enabled during that teaching, just so that they can track what's happening within the data plane. Other examples, so for example, match action tables using exact LPM matching. First, how you can do it using port information, like a packet coming from port 0, send it to port 1. Then doing layer 2 and layer 3 as well. Populating tables at runtime, so how you can use the simple switch CLI or other interfaces as well to populate those tables. Exercises, this is an example here, already mentioned it a little bit, but the learner will be provided with these kind of figures showing what exists within the UDP and RTP, and it's their job to implement the P4 code so that they can do the proper parsing. Another example is how can you implement network address translation, whether it is a source NAT or a destination NAT. And then you have one program that kind of integrates all the concepts, right? From the beginning, like defining headers, parsing, match action tables, all the way till you update the checksum and other stuff that you might want to do in the code. So keep in mind, this is just the introduction one. Then we developed other libraries where we looked a little bit on more features in P4. For example, how can you monitor the switch queue? How can you have a header stack to collect from multiple switches using counters and using meters? How you can use registers, example, calculate inter-arrival time using hashing. How can you generate notifications through digests? All of those stuff are inside this library. Then some security applications. How can you identify heavy hitters using CMS sketch, DNS amplification, SYN flooding, slow loris, URL filtering, and so on. And there's one library, Tofino, so that shows here the Tofino native architecture and different labs so that you can get started. As Dr. Jorge was saying, a lot of the students will start with this library before they start doing research. And a lot of the times they use the platform for research as well, not only for like going over the labs. So we just got another NSF Cybertraining grant, and this grant is mostly focusing on SmartNICs and DPUs or data processing units. And basically this one is in collaboration with UNC Chapel Hill with the Fabric team. And we're gonna talk about Fabric a little bit. This is just started in August 1st. And the goal is to develop some training material to facilitate the adoption of SmartNICs. And this could be for pretty much a lot of different audience. So it can be a researcher, student, can be a cyber infrastructure engineer, like those in campuses in research computing. So the goal is to try to understand how we can use P4 in these SmartNICs. And in some cases, technologies other than P4 as well, and how we can make them available to everyone so that they can do these experiments and learn about these devices with actual physical NICs and virtual NICs as well. So we're gonna deploy those in the cloud that we were discussing first. And also we're gonna integrate them into Fabric, which I'm gonna talk about shortly. And another goal is to integrate those labs also into degrees, right? So if you are undergrad or graduate student, you have access to Blackboard or any other LMS. You can, through the learning and management system, you can basically have access to those labs. So it's integrated as part of the curriculum in the courses too. So what is Fabric? Fabric is an NSF-funded test bed. Initially, it was only in the US. You can see here you have nodes all across the country. And recently, it was also expanded. So you have also connections to Europe and to other places as well. And the idea here is to promote the research and education using this test bed. And they've been using it for a lot of different areas like cybersecurity, distributed computing, storage, 5G, machine learning, and others. And the idea here in Fabric is that you can reserve a certain node in a site. Let's say you want to run an experiment from Florida International University, FIU, let's say to UC San Diego. You can say, well, I want a node here, a node there, and then you'll be given access through a Jupyter notebook to design your experiment. And then you can use it with real system, with actual links. So you have 100 gigs of links all connected. And it's up to you as a researcher or a student to design the experiment that you want and then run it with real devices. So what we notice is that because of its use of Jupyter Hub, it can be very good for the training Fabric, right? And because of that, we started exploring, so what can we do to add some training material to Fabric? And we started initially with a library on P4 using just the virtual switches, the BMP2. You can see here, it's something like this. You have the figure and then the command. Let's say you want to add a network. You select which are the interfaces, you give it a name, and that will create a link between now the two sites. So you can have multiple nodes within one site, let's say in a certain node in Fabric, or you can connect to different sites and have a large-scale network that spans across multiple sites. So this is what we developed so far on Fabric. The same one that we were discussing, the introduction, we ported it to Fabric. We have to redevelop everything because it's a completely different interface. And those labs are available to Fabric users. So if you have access to Fabric, and anyone can have access, I will talk at the end how you can get there. You should see these labs. So we contributed these labs to the Fabric team, and now they disseminated those to everyone that have a Fabric account. So you can start by learning how you can have different sites and deploy the switches and program the switch all the way till you have the experiment up and running. An example here for we have 3 nodes, right? NCSA, University of Michigan, Starlight. We are deploying a P4 switch here. We show, for example, if you want to disable logging on BMV2 to get better performance, you start here developing the P4 code, and then you test the throughput. For example, here we are getting around 1 gig because we turned off the logging on the switch. Another one is you want to measure the queue. So we have a switch here, and it's very easy. I mean, all you have to say, I want this node and this site connected to that other one, right? And then we show how to do all of these connections. You have a switch here in the middle, and there's a collector here in the YANA. Then basically you calculate the queue usage or queue occupancy, and then you create reports and send them to another node, the collector node. So how does a Fabric node look like? You can see here on the right-hand side, you have the data plane element. So these are the switches and routers that connect the different servers. You have a management switch that you use to access the different servers there. And you have some storage, you have CPU, and also that's something that Fabric already has. They have FPGA programmable SmartNICs. So these are P4 programmable. You can write your P4 code and then generate FPGA and deploy it there. Soon they will have P4 Tofino switches. We are discussing with them, trying to see how they can do that. We are kind of negotiating as well with them, trying to provide support as much as we can. And also they have a lot of offload NICs. I'm calling them offload NICs. These are not the latest generation of smart NICs, but something like the NVIDIA Connect X5 and Connect X6. They are all available there. And they also have GPUs and other devices as well. And so in the project that we just got, we're also going to be adding new SmartNICs to Fabric. We're going to be adding the Bluefield 2 or 3 from NVIDIA, potentially Intel IPU when it's ready and we are able to add those. We're going to add more FPGAs there, the Xilinx from Xilinx. These are before programmable, and maybe other SmartNICs if they are available. We developed so far one library that is part of this project, but it's also overlapping with the previous project as well. And this is related to P4 DPDK. And you can see here we have 7 labs, very basic, how you can navigate through the portable NIC architecture, PNA. And for what we have now in the cloud, we are just using virtual NICs just for scalability purposes. We ran a workshop a couple of weeks ago. Andy was there. He gave a very nice talk about PNA. And we had around 50, 60 attendees running the labs simultaneously. And they were able to see how you can write a P4 code, get a DPDK, and then deploy it on the CPU, and then run the experiment. Now we are in the process of porting that library to Fabric. What's interesting about Fabric is that they have more than 15,000 NICs, ConnectX 5 and 6, and these NICs support DPDK. So now instead of using virtual NICs to run the experiment, which you will get maybe 100 megabits per second, that was the performance we are getting. But with those NICs, we are using the physical SmartNIC on Fabric. We ran some experiments when you use multiple CPU cores with a program written in P4, you compile it, you deploy it on those CPU cores, we were able to get 100 gigabits per second. And then I think as well is that other devices have also SmartNICs, so you can run something like DPDK packet gen to generate at high rate. So you will be able to do all of these with guided instructions, and that would enable a lot of research, and you will get also like very good performance there just because of the resources available. Other libraries we have in mind, so we're gonna be going a little bit more in detail on P4 DPDK, implementing some advanced applications and looking more at stateful elements, cybersecurity, fine-grained measurements. Other technologies that we saw are being maintained and actively enhanced in the P4 community, P4TC, P4 eBPF. We're going to be also looking into developing labs for those technologies. And also libraries related to more the DPU/XPU. It's more like the new generation of SmartNICs with those that have CPU cores in them. Something like IPDK, OPI, Sonic Dash, and the others. So the project just started. We don't have all of these, but the plan is to develop similar to what we did with the previous libraries, to develop libraries for those. And most importantly, we need the help from the community. So it can be as simple as sending us what do you see would be relevant for as a learner. What do you want to see? What type of labs, what type of libraries, topics? And also if you can provide feedback, or if we wrote something that's not 100% accurate or can be improved, any feedback would be greatly appreciated and also acknowledged. And that would help us just make those libraries better and better for everyone in the community. Okay, so how can you access the vLabs, virtual labs? I will start first with the academic cloud. That's the cloud system that we described at the beginning of the presentation. You can see here this URL that has all the lab libraries and their PDF content. Each lab library would have probably around from 200 to 400 pages of manual, right? So you can get access to all of these PDFs there. The platform link, so that's the cloud. This is where you're gonna log in to start doing the experiment, to have access to all of these labs and then running those labs. As we know, when you first go to that link, it will ask you for an account. If you want to create an account, just send an email to the email listed here. just state your full name, institution, and role, like student or professor, your email address, and what libraries do you want to have access to. And within 24 hours, 24 to 48 at most, you will have that account and you'll be able to go over all of these libraries. And if you need more information to know how to make the reservation and all of the other details, there's also a guide here, a step-by-step guide that will show you how to get started with the platform. Now, if you are interested in the library on Fabric, currently we just have one library. We are about to finalize the second one, and that would also be available. You need to sign up for an account on Fabric. I just posted here also a link. Now, if you are a professor, you would need to create a project, and through that project, you can enroll students or the learners, and they will have access to Fabric and all the P4 labs that we have there. If you are a student, all you have to do is just create an account and tell your supervisor, your advisor that this is my account, please add me to the project that you have. And that's all what you need to do. Once you are there, you will see as part of the examples, there is P4 labs, and you will see those that we discussed here. Now, what's interesting about Fabric is that you can use it for teaching in a class too. So there's a link here that will show you how you can set up a class. Let's say you want to teach distributed systems or advanced networks, and you want to have some experiments on P4. You can create a class there, enroll the students, and now they will have access to Fabric and they will have access to the P4 labs as well. Also, recently we started creating a version of these labs through Read the Docs. The idea here is to be able to accept contributions from the community. This is an example here you can see. That's for the P4 DPDK. We just created that one. But essentially, you will see the step-by-step, and then you will see the screenshot. And at the beginning of the page here, you will see there's a link that you can use to download the VM. So if you don't want to bother installing DPDK and all the other dependencies and stuff like that, you can just import that file, the VM file, into VirtualBox, and there's a guide that will show you how to do that. And all you have to do after that is start going over the labs. We're going to be doing these kind of read the docs documentation for other libraries as well, and they will be posted on a GitHub page, and you can basically suggest some modifications, or even if you want to add a new lab, you want to contribute, that will be open too. So these are our emails and website for our group. You can see there's other stuff other than what we discussed, like stuff related to research, some other projects that we are running. All of that information is on this website. And I think after this presentation, I can send the slides, and there you will have access to all the links in case you want to have access to the platforms. All right. Well, that's what we have. I don't know if there are any questions.
Yeah, there's one. Is there a P4 Docker image publicly available? I can briefly talk about that. Some labs, for example, the one that we were showing at the beginning, Intro to Cybersecurity, that consists of 7, 8 virtual machines. So it's not one virtual machine. Sometimes you need several virtual machines and several networks. So if you access through the platform, everything is ready. You don't need to interconnect, etc. However, there are some libraries like the Intro to P4 with VMB2 that just require one virtual machine, and we can make that available. Typically, the user just enter into our system, into the cloud, but we will be posting that virtual machine in our website, in the one that is there, Cybertraining. We will make that available. That is for Ramon. Ramon has that question. But just keep that in mind, Ramon. There are some libraries that have so many virtual machines that you will have to download so many and then interconnect and create virtual networks, etc. If that's the case, I would just suggest just use our system that is ready.
Okay. Let me see. So there's a comment from Chris. I would recommend looking at Container Lab as a deployment framework and at Shark for observability. It visualizes the container and network topology in a web graphical user interface and lets you launch Wireshark on any link in the topology. Very convenient. Yeah, that's we did not use Container Lab. We use something called Container Net, which is like a fork of Mininet to allow containers there. But thank you for the suggestion. We will look into that and see if it offers something more than what we have in Container Net. And Container Net's mostly like or Mininet really. You can run Wireshark, specify the interface you want to look at packets at. So all of these are possible, but maybe there's a more convenient or something that helps more with the teaching. So thank you for that.
There's another one that it says controller pods. I will share my screen and answer that one. This is VIDIA controller pods available like ONOS. The answer is yes. This is the website and it's in the chat window. If you scroll down, you see all the libraries that are available. And there is one that is about SDN. It should be somewhere. So it's here. So software-defined networking. And we use ONOS. We discussed in this library from the very introduction, what is OpenFlow, what is a controller, how to communicate between controller and the data plane switches, and so on. So this library is ready. I don't remember how many virtual machines are needed, but if you want to use the library in our system, you are welcome.
You want to take the other one, Dr. Jorge?
Which one, Elie? Could you read?
Yes. Thank you for a nice session. I'm going to check the provided web links. I'm just curious, are all the labs are free to access? I found that there are some labs related to PhenoSwitch too.
Oh, yeah. The answer to that is, if you notice that in this website, all the labs that are listed in the website are open source, except the Tofino. The Tofino is not listed there because you need that NDA agreement with Intel, because you have to access the SDA, software development environment. So we cannot make that available. But you have to get the NDA with Intel.
But the other ones are all free. Everything else is for free.
This is Chris. I have another question, if this is a good time.
Yes.
In your software and hardware labs, do you have packet generators and testers? Are you using any tools for generating and receiving packets?
So for what we have so far, mostly software generators, right? So something like packet gen, DPDK packet gen, this is what we use in one of the library. Others are just based on Python, like simple Scapy just for training, but we don't have any hardware-based traffic generators.
Okay. There are some software generators that are available for free from Keysight, and one of them is called IXIAC. I'm typing this in the chat, and if you go to this sort of landing page called otg.dev, it talks about a vendor-neutral, platform-neutral API for configuring packet testers, and we have software and hardware versions of those, and there's a free version called IXIAC that's pretty performant, and it runs in a container. So it seems like it's something you could deploy, and we actually have container lab deployment examples, etc. So you might want to take a look at that too.
Yes, thank you. Thank you so much. Yeah, I remember I met one time with Venkat from Keysight, and I think he mentioned that one.
Yeah,
I didn't have
he's my boss. I know.
Okay. Yeah, I remember he mentioned that. I didn't have the chance to take a look, but maybe if some of the labs would require like more flexible and granular package generation, we might use that if it is open source and software based, for sure.
I wouldn't say it's open source, but you can download a container image for free. But it's
Okay.
It's a free version of the container. You know, there's different price tiers for performance, and this is a free version that's actually quite high utility. You can, you know, download it off of a container registry.
Okay. Sounds good. Thank you so much.
You bet.
We have another question or comment. We are currently developing a testbed for P4 switches with P4 Docker. It's not based on Mininet. It uses virtual Ethernet pairs, virtual interfaces to establish connection between nodes with a GUI to create the configuration, thus creating a more direct and isolated approach. Thank you for the suggestion of ContainerNet. We will explore the tool and try to understand it. We'd appreciate if you consider our testbed tool. Open source and all feedback are welcome to improve. Yes, thank you. We're gonna be looking at that. When we started with the ContainerNet, I mean, we just wanted to deploy the BMV2 like a container, right? And we want to make all the isolation exactly what you guys are looking at. And we just used a Docker image. We installed there BMV2, and then we pushed it. I think it's on Docker Hub as well. And it was easy to integrate it with the graphical interface of Mininet. So that allowed us to also have like the drag and drop kinds of features in the GUI. I will take a look at the P4 Docker project and see what you guys have, and maybe if there's some overlap, we can also discuss that as well.
I want to add something, the question, because I identify with Ashik Kamal. He was curious about the Tofino switches. Fabric is deploying Tofino, and as you might, Fabric is a platform that is open to a wider community. So I am not sure how they did the NDA with Intel, but whenever those switches are available, I would expect that it's going to be open to anyone in that community. So Ashik, maybe you want to get an account with Fabric, and I think that they are installing the switches, the Tofino on Fabric, and you might be able to access through that in that way. Our labs will be ported. Some of them were ported already to Fabric. So our labs, the one that we have in our private cloud, will be ported to Fabric.
Okay, any additional questions? Okay, thank you both for presenting today. Thanks everybody for attending, really appreciate it. Make sure you subscribe to the P4 mailing lists and newsletter to stay updated for future P4 Developer Day events just like this.